Find the coordinate matrix in Rn relative to the basis B prime. So this is coordinate matrix. You can think of this one as like standard matrix. So what happened if you change the what's going to be the coordinate matrix in this basis? So what it means here is how many of these C1 of 8, 11, 0 plus C2 of 7, 0, 10 plus C3 of 1, 4, 6 will give you 3, 19, and 2. So 8C1 plus 7C2 plus C3 is 3. 11C1 plus 4C3 is 19. And then 10C2 plus 6C3 is 2. So we're solving this system of equations. Now, when I look at this, it may look a little nasty here. So I need to think about these are just C1 and C3. This one is C2 and C3. This one is all C1, C2, C3. So I like to combine these two to eliminate C2. Okay. So if I call this equation 1, if I call this equation 2, if I call this 3, I want to eliminate C2. So happen. So I want to eliminate C2. So 1 times, this is 7 and this is 10. So I want to make common denominator maybe 70. So 1 times 10, oops, 1 times 10 will give me 80 C1 plus 70 C2 plus 10 C3 is 30. And I want to make equation, multiply equation 3 by 7. So 70 C2 plus 42 C3 equal 14. And I'm going to subtract. So C2 can get canceled, right? So there would be 80 C1 minus 32 C3 equal to 30 minus 14 is 16. So now I have, if I call this equation 4, now equation 2 and equation 4, they only have C1 and C3. So if I write, if you look at equation 2, if I just rewrite, this is 11C1 plus 4C3 equal 19. Now, if I look at equation 4 divided by 8, okay, so it will give me 10C1 minus 4C3 equal to 2, isn't it? You know, divide by 8. If you divide by 8, if I divide by 8, that's what I get. I'm getting that. So when I add these two to eliminate C3, I get 21 C1 equal to 21. That gives me C1 equal to 1. Okay, we're going somewhere, right? So C1 equal to 1. So now I can find C3 because, 11 times 1 plus 4C3 is 19. That makes 4C3 equal 8. That means C3 equal to 2. Now, I have C1, I have C3. All I need to do is get C2. So where to get C2? I go anywhere where the C2 is. Now, from equation 3, 10 times C2 plus 6 times C3, which is 2, is 2. So 10C2 plus 12 is 2. That makes 10C2 is negative 10. That makes C2 equal to negative 1. Okay. So now we want coordinate in matrix, a coordinate matrix in relative to B prime is C1, C2, C3, which is 1, 2, negative 1, whereas the standard coordinate was in the book, it is 3, 19, and 2. Oh, wait a minute. C1 is 1. Oh, C2 is negative 1. So sorry. The C2 is negative. I switched this by accident. Okay. So 1 and negative 1 and 2. Okay.